Before God made the world, there was no time. There was no before. What preceded the enormous detonation? Most stargazers would agree that, basically, nothing. Time and space, as we know them, started with an abrupt blast, what we call the huge explosion. In our planetary group, the planets are kept in their circles by a harmony between the sun's gravity pulling them inward and their speed attempting to move them outward. The farther a planet is from the sun, the slower it moves in its circle, which keeps everything in equilibrium. Researchers anticipate that exactly the same thing should occur with stars and systems. Stars closer to the focal point of a galaxy ought to move faster, while those farther away ought to move more slowly. However, when cosmologists measure the speed of stars at the edges of galaxies, they find something astonishing. The stars are moving much faster than they should be. Researchers believe that if stars are really moving faster at the edges of galaxies, you would expect them to take off into space, much like water taking off a spinning wheel. This is because the pull of gravity is much weaker at the outer edges of a galaxy. Yet surprisingly, the stars do not take off. This unexpected speed suggests that there must be extra gravity at play, pulling on these stars to keep them in their fast circles. Researchers find this baffling force very odd because they don't know exactly what it is. It might be a new type of matter, an unknown force, or something entirely different. Because of its mysterious nature, they named it dark matter. This discovery provided the first solid evidence that dark matter exists in our universe. Similarly, there is another invisible force called dark energy, which is responsible for the accelerating expansion of space. Many observations have confirmed that our universe is dominated by these strange, dark substances. Dark matter, which makes up around 27% of the universe, is thought to keep galaxies intact. Yet no one has ever seen it directly. Dark energy, which makes up around 68% of the universe, seems to be causing the universe to expand at an accelerated rate. Together, these forces help explain the structure and development of the universe. Considering the vital role of dark matter and dark energy in the formation of the first stars and galaxies, researchers developed standard cosmological models to describe how the universe evolved after the huge explosion. According to this model, the universe began around 13.8 billion years ago with an enormous detonation. After this, the universe entered a period known as the Dark Ages, when the entire universe was completely dark because it was filled with vast clouds of hydrogen gas. During this period, there were no stars or galaxies to illuminate the cosmos. Even if we had the most powerful telescope imaginable, we wouldn't be able to see anything from beyond this time because the thick gas blocked all sources of early light. However, the James Webb Space Telescope has recently detected a mysterious bright glow coming from within these clouds. This unexpected discovery has sparked a significant debate among scientists, as it challenges our understanding of the universe's early history. According to what we know, no light should have been able to shine through the dense hydrogen clouds of the Dark Ages, making it impossible to see anything from that period. So what could these strange lights be, and where are they coming from? Recently, researchers working on the JADES project, an extensive astronomical survey, identified the Lyman alpha emission line from an object at a redshift of 13. To put it simply, this means we are seeing light from when the universe was only about 300 million years old, much earlier than we ever expected to observe. Lyman alpha outflow from this period is astounding to such an extent that numerous researchers thought it must be a blunder. Lyman alpha is produced when an electron in a hydrogen atom falls from the second lowest to the lowest energy level. In the early universe, after the Big Bang, almost all matter was hydrogen, which eventually came together to form stars and galaxies. When hydrogen gas gets heated up, for example by the energy of a young star, its electrons leap to higher energy levels. When these electrons fall back to lower energy levels, they release energy as light. This Lyman alpha light is in the ultraviolet range, which is invisible to our eyes, but researchers can detect it with telescopes like the James Webb. Now there's a twist. The new discovery of Lyman alpha light only 300 million years after the Big Bang has amazed astronomers worldwide. According to our standard cosmological models, during this time, the universe was so opaque that light from stars and galaxies couldn't easily pass through it. Researchers have found a lot of evidence indicating that the furthest back we could see Lyman alpha light was at a redshift of around 7, which corresponds to about 600 million years after the Big Bang. Even this was surprising, given how much the opacity of hydrogen gas should have blocked the light. Now, they have identified Lyman alpha light at a redshift of 13, coming from a galaxy called Jade's Z13. This is much farther back in time, around 300 million years after the Big Bang, and, according to current theories, should not be possible. One of the astronomers who discovered this galaxy recently tweeted his thoughts on social media, saying, "Seeing the line at redshift 13 is crazy. It's so astonishing that when we saw it in our Jade's data, it almost took the focus away from our confirmation of Jade's Z14 because it was so phenomenal. How is this light finding its way to us through the opaque universe?" Earlier, astronomers discovered the most distant galaxy ever observed, named Jade's Z14, located at a redshift of 14. This means we are seeing it as it existed 280 million years after the Big Bang. The discovery of this galaxy sparked much debate because it has a mass several hundred million times that of our Sun, making it incredibly bright, massive, and large for such an early time in the universe's history. Alongside this, researchers have also found several very unusual objects beyond the dark ages. Scientists suggest that these objects, which appear like galaxies, may be entirely different from what we know. In 2023, astronomers Cosma N. Lee, Gillian Pollan, and Catherine Fry published the results of their infrared observations of the early universe using the James Webb Space Telescope. They revealed 3 objects that could initially be mistaken for galaxies but might actually be dark stars. This discovery has brought the concept of mysterious dark stars into reality. So what is a dark star? The very first stars, forming around 200 million years after the Big Bang, may have been entirely different from normal stars. Instead of being powered by nuclear fusion, they may have been powered by dark matter. At their centers, there would have been a high concentration of dark matter particles annihilating each other. The energy released from these annihilations would have fueled the stars. Following this discovery of dark stars, some scientists now propose that after the Big Bang, which created the universe as we know it, a secondary, the Big Bang may have occurred. This smaller Big Bang could have involved the creation and distribution of dark matter throughout the universe, possibly giving rise to dark stars and other structures we have yet to fully understand. In another groundbreaking study, researchers suggest that our universe may have existed before the Big Bang. This could explain how dark matter came to be. A recent report published in the Journal of Cosmology and Astroparticle Physics suggests that before the Big Bang, the universe went through a phase where it first contracted and then expanded. Imagine the universe contracting to an incredibly dense state, much like compressing a spring. Then, like a spring rebounding, the universe bounced from this dense state and began expanding again, leading to the Big Bang that created the universe we know today. During this contraction phase, tiny variations in the density of space may have created primordial black holes. These early black holes, known as primordial black holes, may have survived the bounce and continued to exist as the universe expanded. Some scientists now believe these ancient black holes could account for what we call dark matter. This theory suggests that our universe has a mysterious past before the Big Bang. However, the discovery of such objects beyond the dark ages has caused a buzz in the field of cosmology and raises many new questions. So far, everything we know about the universe beyond the dark ages is just theory. No one truly knows what lies beyond it. Surprisingly, new images from the James Webb Telescope have revealed strange objects existing beyond the dark ages. This discovery is confounding scientists, as it's unclear how these galaxies could have formed so early. These findings raise a critical question. Are we looking at a completely different universe? Scientists worldwide are now claiming that there is a possibility of a major paradigm shift in the field of astronomy.